All right, another u sub, so cup. So what do I care about? I care about my u, my du, my dx, and my x. So u, I look at my problem. I'm like, what's the trickiest thing about it? Well, this. So I'm going to take what's on the inside. I'm going to make that my u. So that's 4x minus 5. So my du is just going to be my derivative, which is 4, and then times whatever this is, dx, okay? So I solve for dx, it's going to be du divided by 4, and then I don't solve for x unless I need it, and I'll figure out if I need it if things don't cancel out in this part. So I take my integral, put everything in terms of u, so I have 2x, and then the square root, I made this my u, and then I have dx, I'm going to put that in terms of u as well. Luckily I solved for it in terms of u, so that's du over 4. And so this here, I see that, I see that my 2 over 4, that becomes 1/2. I can take those and bring them out. All right. And then I see something very interesting. Things didn't cancel out. Like the x's didn't cancel out. It's still there. So this is a prime example of where you go back and you solve for x. So, and see if that does anything, right? So in this case, I take this and I solve for x. So in this case, it would be u, what the heck? U plus 5 is equal to 4x. And then u plus 5 divided by 4 is equal to x. So u plus 5 divided by 4 is equal to x. So then I plug in x over here. U plus 5 divided by 4. And then I can actually rewrite this to be u to the 1/2. And then what I would do is I would distribute. So this would be u to the first times u to the 1/2. So I can, well, that's really just 1/2 plus 1, which is just 1 plus 2, which is 3/2. So that's going to be u to the 3/2 plus 5u to the 1/2, all divided by 4 du, and then 1/2. Okay, and then you can take out this 1 over 4, so that becomes 1 over 8. And then you can do your stuff. So this becomes plus 1, so you do 3/2 plus 1. That's 2, that's 3 plus 2, 3, 4, 5, that's 5 over 2. So you divide by the reciprocal, actually, my bad, you multiply by the reciprocal, 2 over 5. So 2 over 5, u to the 5 over 2, plus, add a 1 here, so 1/2, right, plus 1, that becomes 1 plus 2, 2, which is 3/2. So this becomes 5. Remember, you're dividing by 3/2 or multiplying by its reciprocal. It's the same thing. I like to multiply by its reciprocal if it's a fraction. So that would be 2 over 3. So that's times 2 over 3. I could just say 10 over 3. 10 over 3. And then u to the 3/2, and that's all being multiplied by 1/8, and because this is an indefinite integral, I can add a plus c at the end of it, or I have to add a plus c at the end of it, I should say. And so this is your answer, but in terms of u, you want everything in terms of x, so you plug u back in because the u actually has the x in it. So you have, let me actually distribute the 1/8 first. So if you take a look here, you have 1/8 times 2. This is 2 over 40, right? Which you could just do 1 over 20. U to the 5/2, and then you have, what do you have? 10, 8 times 3, 24, which if you divide by 2, that's like 5 and 12. U to the 3/2 plus c, and then take this, put everything in terms of u. So plug u in, so that's 4x minus 5, 5/2 plus 5/12, 4x minus 5, 3/2 plus c, and that is your answer. Okay, so this is a prime example of when you do need, or when it's useful to actually solve for x. And the whole idea, that I realized I needed to solve for x is because things didn't cancel out, like the x's did not cancel out. So I solved for x, and with some algebraic manipulation, okay, multiplying this in, I get a really nice thing that I can integrate using power rule. And yeah, and I get this answer right here. So hopefully that helped you out. And let's move on to the next one.